Hi everyone, welcome back once again. We are going to do question 7. We are still continuing with functions, and this is a parabola or quadratic and a straight line or linear function. Okay, from your grade 12 November 2021 past paper. All right, question 7, we're given the graph of f of x is equals to x plus 4, x minus 6 is drawn below, and the parabola cuts the x-axis at B and D and the y-axis at G. C is the turning point of the of f, and we can see that. And there's a line AE that has an angle of inclination of theta that cuts the x-axis and the y-axis at A and E respectively. T is a point on F between B and D. All right, I mean B and G, between B and G. Okay, so 7.1, it says write down the coordinate of B and D. Can you see B? Yes, B, and this is D, right? These are the what? These are the x-intercept of what? Of F, right? How do we get the x-intercept? We let y to be equals to 0 and so for what? And so for x. So where there is y, we're gonna put 0. So it's x plus 4, x minus 6. This is equated to 0. Zero factor rule, x plus 4 is equals to 0, or x minus 6 is equals to 0. Then we know x will be minus 4 or x will be equals to 6. Okay, between B and D, which one is negative? B is the one that is negative. It's going to be minus 4 and 0. And D is the one that is positive, right? So it's going to be what? 6 and 0, right? Okay, 7.2, calculate the coordinate of C. Okay, C, you can see that C is the turning point of F, right? How can we get the coordinate of the turning point? We know that to get the x at turning point, if we know the x-intercept, we know that the turning point is in the middle between the x-intercept, right? So to get the x at C, we can simply add x at B plus x at D and divide by 2, because it's actually the midpoint of the two x-intercepts, right? So it's minus 4 plus 6 over 2. This will give us 2 over 2, and this will give us what? 1. So we know that x at C is 1. Then we can go and calculate y, right? So we need y at C. So we know that f of x, right, is equals to what? Is equals to x plus 4 into x minus 6. So we need f of 1. We need the y at 1, right? So where there is x, we're going to put 1, and we are going to solve for what? We are going to solve for y, right? So this will be 5 into minus 5, and this will give us negative 25, and this is our y at C, right? So basically, to get x, just take the x-intercept, add them, divide by 2, because the turning point is actually in the midpoint of those x-intercept. Then to get to y now, you go, you know your x is 1, so you go on your equation, you replace x by 1, and you solve for y. So we can finally say our coordinate of C is 1 and minus what? Minus 25. So another approach to this, you can have either chosen to expand your equation, right, and write it in the form of x squared plus bx plus c. After expanding it like that, you'd use the formula x at turning point is equals to minus b over 2a. Then to get your y at turning point, you know that you replace your x at turning point back to the equation, and you go and solve for y. So that's another method you could have chosen. All right. Okay, let's go to 7.3. It says write down the range of f. Okay, what is the meaning of range? Range, it means the interval of y, or the values of y in which the graph will cover. Okay, so you can see that the graph turns here, right? This is the graph of f, this one in red, our quadratic, or what is also known as our parabola. This is our graph of y, of f, right? It's turning when x is minus 25. So I mean, when y is minus 25 and going up there, right, up to it reaches what? Infinity. So you can see that the range, what are the values of y that the graph of f will cover? It's from including minus 25 going what? Going upward. Those are the only values of y that the graph will cover. So we can say it's when y is greater or equals to what? Minus 25. Okay, so that will be our range. Or you can say y is the element of minus 25 going towards positive infinity. All right, so but our minus 25 is included, so you must use a 4 corner brackets to show that this negative 25 is also included. All right, and how does this come from? It comes from that thing that you learned in grade 11 to say range of a parabola or quadratic graph. You can say y is greater or equals to q, or rather y is less or equals to q, depending on whether your a is positive or negative. We know that y is less or equals to q when a is what? When a is negative. All right, then here it's when a is what? Is positive. Hence also in this case our a is positive because it's a smiley face, so a is positive. Then we say y is greater or equals to q. So q is actually the value of y at turning point, right? So which is minus 25. So that's why we say y is greater or equals to minus 25. But that is just memorizing, right? That's just memorizing. You can just look at your graph. What are the values of y in which the graph is covering? So it's from minus 25 going upward. Hence we are saying y is greater or equals to minus 25. Okay, 7.4. Given that theta is equals to 14.04 degrees and the tangent to f at t, right? So they're telling you there's a tangent to f at point what? At point t, which is actually perpendicular to what? To AE, right? We can just simply represent that to show, okay, there's actually a tangent to f at point t, which is perpendicular to line AE. 7.4.1, they want you to calculate the gradient of AE, right? Calculate the gradient of AE. So you'll notice that you are given the angle of inclination there, which is 14.04 degrees. Okay, so you might be confused. Are we now doing paper 2? Isn't this paper 1? So that's actually the new strategy that the examiners are coming up with to just integrate knowledge from your paper 2 content into paper 1, so that you may not think in a limited way to say, okay, I'm doing paper 1, I have to think of content in paper 1, but they actually want you to think broadly, right, about a question. If you know I can use paper 2 knowledge in paper 1, you have to use it. So that's actually this new dynamic they're just trying to introduce in your mathematics. Okay, so we are given the angle of inclination. You have to think of what you learned in paper 2, right? Angle of inclination is actually an angle between the x-axis and that line, right? So how can we use this to calculate the gradient of AE, right? So it's very simple. We say gradient of AE is actually equals to the tan what? Tan theta, right? Remember, to get angle of inclination, we say arctan, the gradient of that line. So now we need the gradient of that line. We say what? Gradient of the line is equals to tan theta, and this is the formula that you also know from your paper 2. So gradient of AE will be equals to tan 14.04. all right, so they told us that we must round off our answer to 2 decimal place, so our answer is going to be 0.25. all right, let's go to 7.4.2. They say calculate the coordinate of t. Okay, remember they told us that here at t is where we have the tangent, right, which is actually perpendicular to line what? To line AE. What does that tell us? If two lines are perpendicular, then when we multiply their gradients, they must be equals to -1. and that's your knowledge from paper 2. So don't be limited when answering paper 1. Integrate with what you know in paper 2, because that's what the examiners want you to think broadly about a question. All right. So what we can actually do now is, okay, we know the gradient of the tangent at t multiplied by the gradient of AE will be equals to -1, because the two are said to be perpendicular. All right, so we can actually go and determine the gradient and tangent. What is our gradient of AE? We have calculated it in the previous question, which is 0.25, then is equals to -1. So gradient of tangent is equals to -1 over 0.25. Okay, so -1 divided by 0.25 is gonna give us -4. So this is our gradient of the tangent. Okay, at point what? At point T. All right, how will this gradient actually help us to solve the question, right? Remember, we just quickly calculated, and there was no reason for us doing that, right? We were just told the two lines are perpendicular. Then what came in our mind is, oh, if two lines perpendicular, when we multiply their gradients, it must be equals to -1. Then we solve for the gradient of the tangent at t. But it's actually very useful, right? How? Because we know that actually t lies on f, lies on this parabola graph, right? Meaning that if we can differentiate f, right, if we can get the derivative, right, we know that the derivative at t will actually be equals to what? Will actually be equals to -4, because that's the gradient. Derivative is the same as the gradient, right? Meaning that at t, we know that f prime of x is equals to what? -4, because it's the gradient, right? Remember, first derivative is the same as the what? As the gradient, and here is at point t, right? So it will be equals to -4, because we have already calculated that gradient of the tangent at t, which is what? -4. All right, so let's quickly go and get the derivative. So to get the derivative, we have to first simplify our f of x. So it will be x squared 4 minus 6 minus 2x, 4 times -6, it's gonna be -24, right? So f prime of x is going to be what? 2x minus what? -2. But we know that f prime of x at t, right? We know that I can say f prime of x at t, we know that it's equals to what? This is the gradient at t, right? Because first derivative is same as gradient, is equals to what? -4. All right, so we can say 2x at t minus 2 is equals to what? -4. 2x at t, we can now solve for x at t, right, by saying -4 plus 2, and -4 plus 2 will give us -2. When we divide by 2 both sides, x at t, it's gonna be equals to what? -1. Can you see? We have now solved for one of the coordinated t, and we find it to be what? -1. How can we solve for y? Now the y-intercept of, the y coordinate of t. So we know that t lies on f, right? So we can simply go to f and substitute our x at t, right? Which is what? Which is -1. So on our equation of f, we are just gonna substitute -1, and we simply simplify and get the value of y there. All right, so that's how it's simple. We got x, then to solve y, we just go back to the equation, we substitute -1, and we solve for y. So when we solve for y, it's going to be equals to -21, meaning that the coordinate of t is -1 and what? And sorry about this, and -21. All right, so just a quick summary of this. How did we solve for t? We know that the gradient at t it's actually the same as the first derivative, because t lies on the tangent and also lies on the parabola, right? We know that the parabola or quadratic can be differentiated, and when we differentiate, f prime of x is the same as what? As the gradient. Then we differentiated that, and we had already calculated the gradient using our knowledge in paper 2 to say, oh, we are given that the gradient of tangent is perpendicular to AE, and we had already solved for gradient of AE. We just simply multiply and solve for the gradient of tangent, then differentiate, and we know that first derivative is the same as the gradient. We had already calculated the gradient, which is -4. We just go there and replace and solve for x at t, and we got the answer. Go back to our original function, replace our x, and solve for y. So that's basically what we did there. All right. Lastly, conclude with 7.5. They said a straight line G parallel to AE cuts F at K, which is -3 and -9, and R. Okay, so it's very important for you to understand this statement so that you may be able to answer this question. There's a straight line G, right, which is parallel to AE, right? So we're just gonna make a line that's gonna look like parallel to AE there, right? There's the line. Then it cuts F. This is F, the parabola, right? At K, which is -3 and -9. So on the negative sides here, let's just assume that is our K, which is -3 and what? And -9. Okay, and also it cut F at what? At R, right? So now they want us to calculate the x coordinate of what? Of R. They want us to calculate the x coordinate of R. We don't have it, right? So from that statement to say this line is parallel to that one, we can actually get the gradient of this line G, right? So because they said it's G, so its gradient will be equal to the gradient of what? Of AE, because they are parallel. If two lines are parallel, then their gradients are equal. All right, so this is equals to 0.25. Now we got the gradient of G. We can now go and get the equation of G, right? So that we can be able to deduce the x coordinate of that. Okay, so the equation will be mx plus c. So we know that this is the equation of G, right? So y is equals to what? This gradient is 0.25 x plus c. So how can we go and solve for c? By actually substituting 1 point in the equation, which is k, right? We are given k is -3 and -9. So where there is, this is x, this is y. Where there is y, we're going to put -9. Where there is x, we're going to put what? -3. And so for what? For c. Okay, so when we solve for c, c is going to be equals to -9.75, right? Let's just verify that, because it's going to be -9 plus 3 into 0.25. Let's verify. Actually it's wrong. It's -8.25. okay, -8.25. so that is our c. So we can get the equation of G. It's going to be y equals to 0.25 x minus 8.25. all right, now after getting the equation of this line G, right, how can we now go and solve the x coordinate of R? Okay, very important. So to solve the x coordinate of R, we have to rewrite R in terms of a coordinate. It's x, right, because we don't know it, and y. But with y, we can now replace y, because y is the same as f of x, right? Because this R is on f, right? So y is the same as f of x. So we can rewrite r as x and f of x, which is what? Which is x plus 4 into x minus 6. So that we can now come and substitute our r on our equation and solve for x. When we solve for x, we'll be solving for the x coordinate of r. So that's the strategy that you have to apply here, right? Let me repeat that. We are rewriting r in terms of x and y because it's a coordinate. It must have x and y. But with y is the same as f of x because this r is found on the equation of f, on the graph of f, right? So we can replace y by f of x, and this f of x can be replaced by the equation because it's equals to what? X plus 4, x minus 6, so that we can have the x's there and go and substitute on the equation and solve for x and be getting that x coordinate of r. Okay, so we're gonna substitute our r, which is x and what? And x plus 4, x minus 6, or rather f of x. All right, so this is our x and this is our what? This is our y. So where there is y, we are going to put x plus 4 into x minus 6, right, is equals to where there is x, we have to put x, right? So it will remain like that, minus 8.25. Then we simplify that equation there. It's going to be x squared plus 4x minus 6x is going to be minus 2x. 4 times minus 6, it will be minus 24. When we transpose 0.25x, it will be minus 0.25x. When we transpose minus 8.25, it's going to be plus 8.25. So we'll be left with nothing there on the right hand side. Okay, so we can group the last terms, minus 2x and minus 0.25x is gonna be x squared minus 2.25x minus 24 plus 8.25 is gonna give us what? Minus 15.75. All these are equals to what? 0. Then now to solve for x, we can use a quadratic formula. I'm just gonna write this somewhere here because of space, right? So we're gonna use the quadratic formula, which says x equals to minus b plus or minus the root of b squared minus 4ac over 2a. All right, so x will be equals to minus into what is our b? It's minus 2.25 minus 2.25 plus or minus, let me just put it there, plus or minus the root of b, which is minus 2.25 squared. My pen is writing slow. Minus 4 a, which is 1, and c, which is minus 15.75. Okay, all divided by what? By 2 into a, which is 1. All right, let's see, by 2 into 1. So we can just simply punch our calculator and get the answer. So when we punch the calculator, we're getting x equals 21.4, or x is equals to, let's check, x is equals to minus 3, and this makes sense because at one of the point there where the graph G and F, they're intersecting, it's at minus 3, and we were given that now we got this other coordinate, which is 21 over 4, right? So this is 21 over 4. It's not 21.4, it's 21 over 4, which is 5.25. So that is the x coordinated r. We can finally conclude x coordinated r is 21 over 4, which is the same as 5.25. All right, otherwise, great off. That's all for me. Thank you very much for joining this lesson. we'll see you on the next upcoming lesson. Otherwise, that's all for me, and goodbye.